Hi, welcome to this video on how to insert thrust blocks on a pressure system using Dynamo. I'm running Civil 3D 2020.3 and I'm going to be using Dynamo Player first to insert AutoCAD solids at each corner of the elbow, and then we will take a look at the graph itself. So let's get started. Dynamo Player. And I've created a graph here to insert my thrust blocks. This will insert as an AutoCAD solids based on the selection that I make for the alignment, and that's going to be the vertex alignments, and then the surface for elevation data. And then I'm going to basically, this is a pressure system with 12-inch pipe, so I'm going to put in 12-inch. I'm going to choose the cover I'd like to put the thrust block below surface at, the size, and the appropriate layer that I'd like. And simply run it. And what this will do is it will place, as you can see, a 3D solid. This is an AutoCAD solid object, 3D solid, at each corner, outside corner of each of these elbows. And the nice thing about this is that you can, first of all, you can see it in Object Viewer. This is kind of far, but that can be adjusted. Here is the thrust block, and we can also project this to the profile if we'd like to see it on the profile. So here is my thrust block and profile view. And finally, we can use the 3D solid for clash detection with any kind of nearby curbing or other elements in the ground. So let's take a look now at how this came about. So I'm going to open up the Dynamo graph. And we're gonna go through it step at a time. First of all, we are going to basically simply read the alignment in. We're gonna create some alignment segments from these vertex points. The reason is we need to figure out the angles between each segment so that we can align the block nicely centered between the two segments. And then we're going to figure out which side of the alignment we need to put the block on. We need to offset the point just a little bit to accommodate for half the width of the size of the pipe. And then we're going to read in the surface, figure out the elevation on the surface, and figure out the elevation of the block, accommodating the cover. And then we're going to create the solid geometry in Dynamo and send it to AutoCAD. So let's go through this one step at a time. We're going to go read the alignment. I'm going to get the alignment stations. Really, I'm really interested in the geometry stations. Those are the PIs. And this, from there, I can figure out the coordinate system at each of these vertex points. So notice there is no offset just yet. I'm just interested in the vertex points. And then I'm going to get a point. Dynamo point. So let me run this at one step at a time. So if I run this small segment, I basically get the vertex points. Okay. So at this point, I need to connect them with lines, and so I did that. A start point, end point. Each point I connected it with a line. Pretty simple. And then I have two methods of figuring out the angles on these lines. First method is getting the angle of the line, or the bearing of the line, and then measuring the angle between them. The issue is that I found it to be very long and lengthy process to figure out the angle between the two lines, or vectors I should say. And it was a lot more difficult to figure out the side as well. So angle took a long time, the side was kind of even longer. So what I found to be handy is getting a curve in there and figuring out a curve was a lot easier and shorter. So I put in a temporary fillet between each segment, and that's what this one did, the arc fillet. And most of these nodes are included in the geometry library. The coordinate system nodes are in the abstract library, and the curves library contains the dynamo geometry here, so I used the arc geometry. At this point, after I did that, let me run this portion. And in the background here, we'll see that we now have small little arcs, and I chose a small little radius here of only 5-foot radius. From this point, I created a vector that went from the midpoint of the arc to the center point. So it's basically a perpendicular vector from midpoint of arc to center point. And the midpoint is a parameter. So I have curve normal at parameter here. This is my normal vector, and it's at the middle. So parameter 0 is the start of the curve, parameter 1 is the end of the curve, so parameter 0.5 is basically the midpoint of the curve. And then this one was going into the center, so the vector was going into center, and I needed all my thrust blocks to be on the other side. So pretty simple, just reverse the vector. That would give me the point outside. So at this point, what we needed to do, we got the side, or we got the rotation, so I just simply created a coordinate system from the vector for rotation, and the coordinate system was at the point outside, and then I needed to offset that to accommodate for pipe width, half the pipe width. So here is my pipe size, and I'm going to translate it. Translate is like an AutoCAD move. I'm translating my coordinate system outside with the half the pipe width, and then I get another point. So let's run this portion. So as you can see in the background, we now have a coordinate system at the vertex that is aligned to the curve, and then I moved that outside with the to accommodate for the pipe width. At this point, all I need to do is figure out the elevation at this point. So I redone my surface, get the sample point at the surface, get my elevation, calculate the elevation plus the cover desired, or the cover used to design the pipe or pressure system. And then after that, I translate this vertically this time on the z-axis, translate it down to figure out the elevation of the center point of my cube. So let me do that portion. So this one got moved down. And then at the very end here, this is the happy part. Create a dynamo solid and send it over as AutoCAD geometry. So that was all the graph entailed. Let me create run it automatically now for special effects. And I'm going to freeze the pipe, run this automatic, and as you can see, it placed all my (3D) solids on there, and they are always going to be aligned to the alignment. Really not doing anything with the actual pressure pipe. As you can see, the solids are moving and updating. And that's all I have. Thank you for watching.